Okay, so hopefully you got 3.1 certified done. I know that's not one of the easier ones. It's probably one of the hardest certifies we've done this year. But with that being done, we're going to use that domain and range and even and odd function stuff throughout the rest of the year for the most part until we get to the end. But we're going to talk about all about graphs from here on out. So today is more about analyzing the graphs of functions. So there's some key terms that go into this. So I'm going to start right here with the definition. A function can be increasing, decreasing, or constant on an open interval. These intervals are given using the x values along the x-axis. So that's really important that we're using the x values along the x-axis. Another definition I want to talk about is end behavior of a function is defined as the behavior of the graph of f of x as x approaches negative infinity to the left and positive infinity to the right. We denote end behavior using the following, and I'll show you what it looks like whenever you write it out. So a function can have a relative extrema, aka a relative maximum or a relative minimum. It's called relative extrema because it's like whatever in that neighborhood is the relative max. That's what we define it as. So here's an example. I'm going to give you a graph. Intervals of increasing, decreasing, or constant. So when you do intervals of increasing, decreasing, or constant, you're like reading the graph from like left to right. So if I start with the far left and then I go right, notice my graph is going up. So we would say that is increasing. And we're only looking at the x values. So if you look at those coordinates, it's increasing from -4 to -2. And we use open parentheses, open intervals, because at that interval, -2, it's going to change directions, aka decrease or be constant. And so then if it's changing, it's not going to be increasing anymore. So it's increasing from -4 to -2. And if I keep following my graph, notice now it starts to go down. So from -2 to 3, it's decreasing. All right? And then I keep going, 3 to 4, now it's increasing again. So you could have multiple intervals of increasing or decreasing or constant, it just kind of depends on the problem. And then from 4 to 5, notice it's a flat line. So we call that a constant. So from 4 to 5, it is constant. And then lastly, as I keep reading from left to right, 5 to 6, that is increasing. Okay? So that's intervals of increasing, decreasing, or constant. It is possible to have negative infinity or positive infinity. It just kind of depends on the problem. Notice these ones don't have arrows that go on forever. They're actually points, so just keep that in mind. So just to show you what I mean, if this would have been an arrow going on forever, I would say from negative infinity to -2, it's increasing. Okay? End behavior, you're just looking at the end of the graph. So say these lines go on forever. All right, if I look at the end of my graph, so as x goes to negative infinity, so as I keep going to the left, what is your y value doing? Well, f of x is going down, so it's also going to negative infinity. So end behavior is either going to be positive or negative infinity. But if your line's going down, it's going to be negative infinity. So as I go to the left, I'm going down. As I go to the right, aka positive infinity, my y value is going up. So I'm going to say it goes to positive infinity. And that's how we do end behavior. Relative extrema, so a relative max. An example of this would be one of the highest points that's not at the end or the beginning of the graph. So that highest point would be right here. So my relative max would be 4.5 at x equals -2. So that's your y value. Relative max is your y value. Relative min, again, is the lowest point that's not going to be the end of your graph. So that would be down here. So it's going to be -8 at x equals 3. And that's how we do relative max, relative min. It could have one or the other. It could have neither. It just kind of depends on the graph. So you don't always have to have a max and a min. You can just have one. You could have a max or a min. Again, it depends on the problem. So that's intervals of increasing, decreasing, or constant in behavior and relative extrema. The last thing we talk about is the zeros. So the zeros of a function of f are the values, or the x values for which f of x equals 0. So real zeros are the x-intercepts of the graph. So where it crosses the x-axis. So what are the zeros of the function to the right? Well, if you look at it, it crosses the x-axis here, here, and here at these 3 points. So the zeros are x equals, we're going to say it's negative 3.5 because between negative 3 and negative 4, x equals 0, and x equals, looks like 5.5 because it's between 5 and 6. So the analytical steps that we take to find the zeros is something we're going to resort back to that we've done before. Normally you're going to factor out your GCF, and then you're going to factor using AC method or traditional factoring, which is where it multiplies to the last number, adds to the middle. You could also do grouping here, which kind of depends on the problem. And then your third step, if you have to, if none of those work, you would say the quadratic formula. Okay? So it says find the zeros analytically of each function, confirm results with the graphing calculator. So x cubed minus 4x. My first step is to factor out the GCF. So my GCF is x, so then I have x squared minus 4. Well, factoring rules, we've done this before. X is fine. X squared minus 4 can be factored again. That's a difference of 2 perfect squares, so that factors into x minus 2, x plus 2. So that would be something we call traditional factoring. It's a special rule, but you've seen it before a whole bunch. It's just a matter of remembering it. Now, once you get down to factor completely, you're going to say, all right, set them each equal to 0 and solve them. So x equals 0, I don't really have to solve anything. The other ones I need to add 2 and subtract 2 to get the roots. So I have x equals 0, x equals 2, x equals negative 2. Now a little hint, this is a cubic function, so that means you're going to have 3 zeros. Okay? If I would have had plus or minus something, right? The plus counts as 1 0, the minus counts as another 0. It just depends on the problem. So that's the first example. That's one of the easier ones. Next up, we have something like this. So if I factor out 2x, I'm going to get x squared plus 2. Now, x squared plus 2 can't be factored using any of the methods. However, we can also use the square root method. So if you don't have 3 terms to do the quadratic formula, you can still do the quadratic formula. It's just a little bit harder because you're going to use 0 as your b. Instead, what we like to do is the square root method. So we're just going to set each of them equal to 0. And now we're going to solve it. So the first one, I'm going to get 0. The second one, I'm going to end up subtracting 2 and then square rooting it. When you square root it, it's plus or minus. And I'm going to do I squared root of 2. Remember, because if it's negative, it's going to have I. So there's 2 roots, and this is the third, right? And it's x cubed, so that means I'm going to have 3 roots. So the first one is 0. The second one is a positive I squared root of 2. And the third one is a negative I squared root of 2. So that's how you know I did it right, because you got 3 roots at the end. Lastly is something like this. I can factor out an x, so then I have x squared plus 2x minus 7. Notice x squared minus 2x, or x squared plus 2x minus 7 cannot be factored using traditional factoring, so I have to do the quadratic formula. So don't forget, your a is here, so my a is 1. My b is in front of the x, so that's 2. And my c is at the end, so that's negative 7. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I solve this, I'm going to get negative 2 plus or minus the square root of 4 plus 28 all over 2, which is negative 2 plus or minus the square root of 32 over 2. So then you would get negative 2 plus or minus, we need to simplify the square root of 32. So 4 and 8, 4 and 2, I can make a pair of 4s there. So it's going to be 4 square root of 2 over 2. I need to divide everything by 2, so I would have negative 1 plus or minus 2 square roots of 2. So there's 2 roots. Don't forget at the beginning we factored out an x, so I would set that equal to 0 and solve it, and that's my third root. I know there's a lot of steps to do this analytically, but it's something you're going to have to get used to because it's going to help you graph the problem if you have to graph it using the x-intercepts. Okay? So that's it for today. You have paper homework. It's attached to the Google Classroom post. If you have any questions, please let me know. Otherwise, have a good day.